Welcome to the Nexus News, Space Report, Episode 1. All links will be in the description box below. Exploring the lunar mystery of the hollow moon. The moon has always captivated humanity's imagination. Its serene presence in the night sky, coupled with its enigmatic history, has fueled numerous speculations and theories. Among these, the notion of a hollow moon has gained attention, intriguing ancient astronaut theorists and curious minds alike. In this article, they delve into the intriguing claims presented by the History Channel's Ancient Aliens Season 11 episode, titled The Hollow Moon. They explore the evidence and questions surrounding this controversial theory that challenges conventional lunar science. One of the most perplexing pieces of evidence comes from the Apollo missions. On November 20th, 1969, during the Apollo 12 mission, astronauts intentionally crashed the launch vehicle back into the moon's surface. The result was unexpected and astounding. The moon began to resonate like a giant bell, a phenomenon captured by seismographs for over an hour. Subsequently, during the Apollo 13 mission, an even heavier part of the rocket was crashed into the moon, causing it to ring for over 3 hours and to a depth of over 20 miles. This seismic resonance was not what the scientists had anticipated, and it continues to puzzle experts today. Google Moon hiding alien base. Recent revelations have sparked immense curiosity around structures found on the moon, hinting at the possibility of sentient beings having left their mark. Reports of unidentified spacecraft sightings near Selena have further fueled speculation. However, this discovery isn't just about cosmic intrigue. It's become a covert arena where global powers vie for control over our celestial neighbor. And at the center of this exploration lies Google Moon, a gateway not only for academics, but also for individuals and unconventional researchers to scrutinize lunar landscapes. One standout finding involves a group of amateur investigators stumbling upon an image in Google Moon's repository, a mysterious structure spanning a colossal 15 kilometers across Selena's surface. Their immediate conclusion? An extraterrestrial stronghold camouflaged in plain sight. Asteroid 319 Leona. Imagine your favorite constellation without one of its brightest stars. For a few seconds on the night of December 11th and 12th, this may happen to Orion, at least for viewers along a narrow path from Central Asia and Southern Europe to Florida and Mexico. Around 1:17 UTC December 12th, 8:17 p.m. Eastern December 11th, the main belt asteroid 319 Leona, Betelgeuse, the orange-red star marking Orion's shoulder, and block at least some of its light for up to several seconds. An occultation of the first magnitude star is rare. Such an event is visible from Earth only every few decades, but recording one can give astronomers valuable scientific information. By precisely timing the duration of the occultation from many sites simultaneously, they can refine the size and shape of the asteroid. This time, they may even be able to map Betelgeuse's strangely large convective cells, by which the star brightens and darkens for months at a time. Betelgeuse is the 10th brightest star in the sky at magnitude plus 0.5. So observers need only modest equipment to make a valuable recording, but you have to be in the right place. Big Bang is not the beginning. Sean Carroll is a physicist at Caltech. His research includes theoretical physics and astrophysics, especially cosmology, field theory, and gravitation. He has published several research papers on dark matter and dark energy, modified gravity, violations of Lorentz invariance, extra dimensions, topological defects, cosmic microwave background, causality violation, black holes, and the cosmological constant problem. He is currently focused on origin of the universe and the arrow of time, including the roles of inflation, baby universes, and quantum gravity. In his recent video, My Tech Insider, he explains what existed before the Big Bang and what it actually means. The Big Bang Mirror. In November 2018, 3 physicists from the prestigious Perimeter Institute for Theoretical Physics in Waterloo, Canada, proposed an extraordinary idea. From the Big Bang, not only the universe we know, but also another one that is its image in the mirror arose. In an article then published in Physical Review Letters, the physicists Latham Boyle, Karen Finn, and Neil Turok thus argued that the universe we live in is only a part of a real universe, and that if so, 2 of the largest problems facing physicists, namely dark matter and inflation, would cease to make sense. In fact, dark matter, the mysterious substance that accounts for almost 1/3 of the mass of the universe, and that the scientists are unable to observe, would be nothing more than a new type of neutrino, meaning not yet observed. And the period of inflation, which exponentially expanded the size of the universe shortly after the Big Bang, and whose mechanism is still unknown, would simply no longer be necessary. Now, in a new study just published in the Journal of Physics, the same researchers extend their work and explore what this anti-universe, in which everything goes backward, would be like. And their conclusions are really fascinating. As astrophysicist Paul Sutter explains in Live Science, further experiments to search for gravitational waves or to specify the mass of the neutrino could clarify, in the coming years, whether or not this mirror universe really exists. River of Stars. A stunning river of stars has been spotted flowing through the intergalactic space in a cluster of galaxies about 300 million light-years away. Such bridges are known as stellar streams, and at a length of 1.7 million light-years, the newly named Giant Coma Stream is the longest we've ever seen. And that's not all. The faint river is the first of its kind ever seen outside the galaxy. The discovery is a huge surprise. In such a dynamic and gravitationally complex environment as a galaxy cluster, something as tenuous as a stellar stream isn't expected to last very long at all. Yet here we are. The find can be used to study galaxy clusters in more detail and the mysterious, clumpy, dark matter therein. This giant stream crossed our path by coincidence, says observational astrophysicist Javier Roman of the University of Groningen in the Netherlands and the University of La Laguna in Spain. We are studying halos of stars located around large galaxies. Cosmic ray smacked Earth. A cosmic ray that smacked into Earth's atmosphere has absolutely gobsmacked astrophysicists. The tiny particle was carrying in excess of 240 exa-electron volts of energy, or 24 times 10 to the 20th power electron volts, second only to the famous mind-blowing Oh My God particle detected back in 1991 with its 320 exa-electron volts. But here's the sting in the tail. Just like the Oh My God particle, scientists were unable to track the new one to an obvious source. The particles are so high energy, they shouldn't be affected by galactic and extragalactic magnetic fields. You should be able to point to where they come from in the sky, says physicist John Matthews of the University of Utah and member of the Telescope Array collaboration that made the discovery. But in the case of the Oh My God particle and this new particle, you trace its trajectory to its source, and there's nothing high energy enough to have produced it. That's the mystery of this. What the heck is going on? Giant void in space. One of the biggest mysteries in cosmology is the rate at which the universe is expanding. This can be predicted using the Standard Model of Cosmology, also known as the Lambda Cold Dark Matter ACDM. This model is based on detailed observations of the light left over from the Big Bang, the so-called cosmic microwave background, or CMB. The universe's expansion makes galaxies move away from each other. The further away they are from us, the more quickly they move. The relationship between a galaxy's speed and its distance is governed by the Hubble constant, which is about 43 miles or 70 kilometers per second per megaparsec, a unit of length in astronomy. This means that a galaxy gains about 50,000 miles per hour for every million light years it is away from us. But unfortunately for the Standard Model, this value has recently been disputed, leading to what scientists call the Hubble tension. When we measure the expansion rate using nearby galaxies and supernovas, exploding stars, it is 10% larger than we predicted based on the CMB. And that's your space report from Nexus News, Episode 1. Thanks for watching, and don't forget to like, share, and subscribe. You know, the thing. You can find us on YouTube, Rumble, and Facebook.